Good morning, everybody. Assalamu alaikum wa rahmatullahi wa barakatuh. This is the first virtual field trips that I am conducting for the Geology 2 students. As you know, field trips is very important for to understand what you have learned in class. So I will try to do my best to explain some of the important features here in Rusail and in Al-Kiyumi, so you can listen and try to link it with your information in the class. So before I do that, I will start to introduce you to the geological column of Oman. So we will have an idea where we are and what we'll be looking for. So if you look at the geological column of Oman here, you can see here the first unit that is present. We call it supergroups. The first one is the A supergroup, and then we have the B supergroup, and then we have the C supergroup. What is an A supergroup? A supergroups, this is what we always call it we call it here, but we will not see it here actually in the Rusail area. But we call it the pre-Permian rocks. Pre-Permian, that means anything older than the Permian, it belongs to this supergroup. The pre-Permian rocks can be well exposed in some other areas in Oman, especially if you go to Wadi Bani Kharous, for example, or Wadi Ibn Umar, or those, you will find a very nice exposure of these pre-Permian rocks. Then if you look at here, a continuation of the supergroup A, there is here angular unconformity, very clear and very nice. That is separating the lower pre-Permian rocks from what we call the Hagar supergroup rocks. This angular unconformity is well recorded. One in Wadi Bani Kharous, that as you can see here, after the formation of these pre-Permian rocks, has been tilted and then eroded, and then another rocks has been deposited on the top of this one to form the Hagar supergroup. Hagar supergroup, this is the shelf, and we'll explain later on how they form. But we call it the shelf carbonate rocks. And probably we'll see some rocks here from a distance. Then after the deposition of these Hagar supergroups, the geology of Oman has been changed dramatically, and the supergroups B formed. The supergroup B, it is an ophrite sequence, so it's an igneous. The igneous rocks is the ophrite, as we know. The ophrite, as I told you in the class, is a sequence of rocks starting with the ultramafic rocks, Hasbargites and Donites. We call it collectively Birudais, and then it comes to the upper part of the ophlites. We come to the gabbros, the layered gabbro, which is the crust, and then the massive gabbro, and then we come to the shitty dikes, and then the zero lava, and then the sediments on the top. We'll try to see some of those rocks. Some of them we see them here, the others will see them in the area. In addition to these rocks, there is a window. We call it the Hawasina and the metamorphic soil. The Hawasina is the church that has been formed at the bottom of the ocean. It's a church and the sandy church, something like that. And you will learn about those in detail when you study geology of Oman. The abduction of the flight in Oman, it has many theories. We are not here in a position to explain how it's abducted, but just simply when the oceanic crust comes, it's been moved and abducted on the top of the Hagar supergroup. So this is the shelf, and this is the ophrite. It comes like that, and it seems to me that it starts, say, 1995 million years, ending 70 or 75 million years. That means it talks about 20 million years for these ophlites to move from the ocean to the shelf carbonate. After the formation of this B, of course now B is igneous rocks. It has been exposed to the surface, so the weathering products will start, or the weathering process will start. Weathering, as I told you, that it could be physical weathering or chemical weathering. Here we have both. When we have physical weathering, it forms what we call the fault conglomerates. A lot of conglomerates that we see in many areas in Oman. We call it the fault conglomerates, and this is contains all kinds of pre-existing rocks, the ophelites and the Hagar supergroups, the Permians, all those have been deposited in the fault conglomerate. And at the same time, there was a chemical weathering of these ophelites, and it forms what we know here the laterite. We'll show you later on some photos or some pictures of these laterites, which is chemical products or chemical weathering of pre-existing ultramafic or maybe ultramafic rocks. And then after this abduction and weathering, there is another sequence of deposition, shallow marine deposition, which forms the C supergroup. The C supergroup we call the tertiary, actually the tertiary, and it is composed of limestones, sands, and shale, but and can be divided into a number of formations. We call the Hussein formation, the Seed formation, and other things. But we do not worry about those formations. We just say here we call it the tertiary or the Seed formation, or the Seed formation. And this is a very simple sequence of the stratigraphy of Oman. And now we'll try to go and see some of those rocks and how we identify them in the field. And as you know, that every geologist has to have some kind of tools. For example, geologist, he has to have the hammer with him. He has the compass to use and measure the strike and dip, and he has the HCl bottles to test some of the rocks if they have carbonate or other things. And the lens is very important, of course, to identify in the field some of the minerals. And then later on, and lastly, that we have GPS that probably if you read it sometimes to locate yourself exactly where you are in the map. And those tools are very important for any geology to do important list for now. Okay, thank you. Okay, here we'll look at one of the major structures, and I want you to follow me from this point exactly here, where you see the tracks there. You can see where is the dip of the rocks, and then I want you to go all the way to the cement factory, and then goes farther to where you see the water tank over there on the top of the mountains. If we look carefully about this structure, and we'll find the rocks here dipping this way to the west. Here is the east, here is the west. So those rocks are dipping to the west, and then we go all the way like that, and then at the end there they are dipping to the east. So it seems to me that we have a major syncline. We have a major syncline here, like that, dipping this way and dipping this way and going this way. So this is a major syncline, and we know how syncline formed by compressional forces. So this area been subjected to a compressional forces, and if you look at the rocks there to which supergroup they belong, as we can see them, they are grayish to yellowish in color. So this is all carbonate, which belong to the C unit, the tertiary unit, at the top of the stratigraphic column. And this is one thing I want to show you here. Look here to examine those rocks, and when I try to break it, it breaks along very nice surfaces, and this indicates that these surfaces are weak. So this is type of foliation, and foliation, as we know, in metamorphic rocks, and we call this a schistosity because it's a schist here. And if I break it again, it will break with the same trend. Maybe I was not lucky, but I was not lucky, but it will break with the same. Here, maybe this is another place, and if we have another rock, maybe if we break it, anyway, they will break along all these weak planes. And if you can see these shiny minerals, they are mostly mica, and you can see they are very shiny. And so this is one way to identify metamorphic rocks, by looking at the schistosity type, and it's easy to break along those planes or surfaces. Here we are now standing on the metamorphic soil, which I show you. If you go back to the geological column of Oman, you will see there is this called a metamorphic soil that was formed in the wedge during the abduction of the ophiolite. So this is a metamorphic soil, and if you look farther there, at the far end, this is the Hagar supergroup there. So that means those rocks has been moved this way towards the Hagar supergroup. The Hagar supergroup is the shelf carbonate. So it seems to me that those rocks all the way just moved this way and along the Hagar supergroup, and you can see some of the reddish color rocks on the surface. This is the lasfinite that I told you last week or early this week about lasfinite, how they fall due to the hydrothermal alteration of serpentine or in general ultramafic rocks, producing what is called the lasfinite rocks. It's a reddish color that extend all the way towards Halban area. Outcrop showing as the recumbent fold, and this is, as you can see, the two limbs, and this my stick now is parallel to the axial plane, and this fold usually to be upright but has been refolded or recumbent to be parallel along the two axial planes of the fold. Yeah. Fold that you can see, this is the fold plane, and we can now identify where is the hanging wall and where is the foot wall. The hanging wall on here, this is the hanging wall, and this is the foot wall. And if we try to identify some of elliptical rocks on both sides of the fold plane, we'll see this one is probably this one, and this one is probably this one. So that means this hanging wall has been moved down relative to the foot wall, which is a normal fault, which is described as a normal fault because the hanging wall moves down relative to the foot wall. Okay, we look at this outcrop. This is actually part of the metamorphic soil. It is metamorphic rocks. It's a combination of quartzite, multicolored quartzite and marble, as you can see here. But this, what we want to show here, that those rocks has been subjected to intensive deformation, and this deformation can be represented by macro-folding and macro-faulting. As you can see here, some of these rocks has been folded, like this one, which reflects the whole fields, but this is micro. The other one was macro. And look at this one also, and more and more here. You can see, look inside of those rocks that they have more folding, and in the meantime if you look carefully here, look at this, come here and look at this one. You probably see like that. Maybe like that, maybe this is another faulting, and this is the hanging wall, and this is the footwall, and as you can see the hanging wall raised up, that means it's a reverse fault, because the hanging wall moved up relative to the footwall, and many of those microstructure can be found here, which reflects the extensive deformation of the metamorphic soil. Okay, now we are in another location which shows marble, which is metamorphosed limestone, hydrothermal thermal metamorphism of limestone. The location of this one is related to the geology of Oman. It's not really well understood here. It could be part of these oxytics that has been formed at the bottom of the ocean and then has been transported to here. And if you look at it, it's a good marble. I don't know why it's very strong, but we are getting there. Look at this. This is the marble, white marble, and just in case you put some HCl, it will react, but it's very slowly reaction, not like the limestone. You can see some of this reaction because it is calcium carbonate metamorphosed, and the reaction will be slower than the pure or metamorphosed limestone. So this marble is good for industry, and there is a number of locations here in Oman of marbles, and they've been used for the local and probably for the international market. Okay, we are here in the laterite location, and as you remember from your last week lecture when we were talking about the type of the weathering, this is a typical chemical weathering, especially oxidation. And what's happening here, those are the top there, those are the protolith, the original rocks, which is part of the ophelites, could be periodized rocks here. And during their chemical weathering, the elements will start to leach down, leaching of the elements, lifting the iron behind. So when all the elements go through the solutions, the iron will remain because the iron is very slow to move, very lazy in fact, and will form the laterite soil. The laterite soil, as we said, is an iron-rich soil. And if you look close, you see how those rocks look like. You see, this is the laterite. They are very rich in iron, also in clay, and you see also you can see here some manganese, probably manganese oxide. This one. Laterite here used for cement factory, in fact, but around the world they are a source of nickel and cobalt. Most of the, probably 75% of the land resources of nickel are coming from the laterites. So somebody has to pay attention to look at the economic potentiality of those laterites in terms of nickel, cobalt, and manganese. And we have done some studies on that, and if you need further information regarding the concentration of those elements, you ask me or go and search for the nickel laterites in Oman, and you find in the internet. But they are very nice, colorful, compact, and of course very dirty. And they said because the amount of hematite is very rich, in the past, the Egyptian pharaohs and then the Queen Cleopatra, they used this one as a makeup in her face, and the ancient people, they use it as a pigment for their work. Photolith there, the original rock that has been leached, and then the elements moved down, the iron remains behind, forming the residual that I was talking to you. What we say, the material that has been left over when you are boiling tea or coffee. There is a material that we will remain behind, الدهنة that we were talking about. And the location of the laterite in Oman is in very few places. This is one, and the most extensive laterite exposure is in Wadi Nam and close to Ibra and those areas, and a little bit also in Wadi Dhiqa, close to Wadi Dhiqa, in Tui, in the town is called Tui. Those rocks is a gray to yellowish in color. This is the tertiary group C, tertiary carbonates. Now we will go and look at those tertiary, which is capping the laterite. We'll go now. We'll see on the other side. We'll go and see how those carbonates looks like, and we'll do some measurements on them. We are standing here on the off-light rocks, which is an igneous rocks. And if you look at here, this is a sedimentary conglomerate that belongs to the Quaternary time. So the igneous rocks and then the sedimentary rocks, and the contact between them is called unconformity. So if we want to know the gap between those two rocks, probably here is late tertiary and here quaternary, so you'll find several million of years between those two rock units. This belongs to the supergroup B, and this is probably to the quaternary, or I'm not sure, maybe they to supergroup C, or just we call it the quaternary period. Okay, now we are standing on the layered gabbro. Once again, I like to remind you where is the layered gabbro in the off-light sequence. This early morning I mentioned the lower part of the off-light is the ultramafic, which is the mantle rocks, and then we come to the moho, and then again to the crystal rocks, which is starting with the layered gabbro. So now we are standing on the crust, and these patches is layered gabbro, this one and this one and this one, along the wadi, mostly layered gabbro with some whorlite rocks, the black ones here, like this one, whorlite. And if we go further there, this looks to be the mantle rocks, which is the hasbargite or the peridite in general. So if we assume, or if we are sure that those mountains on the back, they are the mantle rocks, and we are here at the crystal rocks, that means the moho zone maybe is running parallel to the wadi here, but at depth. So this is one indication that we are close to a moho zone, but it's not clear on the surface like in other places in Oman. For example, the best exposure of moho is in Wadi Abyad. So it's maybe running here. But now come and look at the layered gabbro, what they are exactly. And let's see this outcrop, for example. This is the layered gabbro, as you can see. It's a layers of black minerals and white minerals. When they formed, this is of course a magmatic rocks. When they formed, the minerals, which is heavier, will start to crystallize and forms, which is this one, composed probably pyroxenes and olivines, and then it comes to the more feldsparic minerals, the white bars. So it's layers of of alternating minerals of black and light minerals, the ferromagnesium minerals, and then the feldspathic minerals. It's a very interesting rocks within the crust of the ophiolite of Oman, or the Samahil ophiolite. This is the whorlite. The whorlite composition is between olivine and clinopyroxene. We call it whorlite. And if it is olivine and orthopyroxene, we call it hespergite. See, the whorlite is always close to the with the layered gabbro, close to the transition zone between the mantle and the crust. But it is dark in color, has very characteristics. So, and ultramafic rocks, of course. And this is mafic rocks, the layered gabbro, mafic rocks. And you can see the big crystals, very nice. Now we are at the sheeted dike outcrop, and as you remember that we said above the layered gabbro, we come to the sheeted dikes in the ophiolite sequence. Those sheeted dikes is the feeders for the below lava that we'll see later on. If you get closer here, this is one of the dikes. This is supposed to be close to the mid-ocean ridge. What's happening when there is a magma comes up through fractures, before it reaches to the surface to form a below lava, it will solidify beneath and form these dikes. So every time a new lava comes, will push the old one on both sides. So the younger dikes will be at the center, and then getting older and older, which reflect the rate of spreading in this mid-ocean ridge. I have read in the literature that the spreading rates here of the mid-ocean in Oman is considered fast, probably around 90 millimeters per year or so. So producing a lot of sheeted dikes. If the rate is very slow, less than or equal or less than 40 millimeters per year, that the dikes will be less, and it will form in a depression-like or a rift valley rather than in this way. So that intensity or the amount of the sheeted dikes will reflect the amount of the magma, solidified magma, and consequently the rate of the spreading. So as you can see here, it's very nice, and between dikes and dikes you will find a shield margin, which is composed of altered materials, and of course those dikes could be basic to andesitic in composition, volcanics. Okay, so it's very good exposure. Unfortunately, most of those exposures of the sheeted dikes had been blocked by the new house construction here. So this is the only outcrop that probably remain, and probably a year from now or less, it will be covered totally, and we will not be able to find it here. Okay, we are here in the locality of below lava. As I told you earlier, the sheeted dikes comes up. If it continues to come to the surface, it will form this below lava on the bottom of the ocean. What is billows? Billows, looks like billows. It's like this shape, as you can see here. This is not the perfect outcrop compared to other places, especially in Wadi al-Ghazi, one of the best billows around the world. But here there is some billows that's been formed at the bottom of the oceans, and then has been transported with the rest of the ophiolite to land. So this represents the most upper part of the volcanics, which is within the ophiolite sequence. The direction of the billows is very important. If they are vertical like that, that means there is no tilting or no deformation have been occurred on those. But if it's tilted, that means those billows has been tilted a little bit while they are abducting to the land of Oman. Billow is important not only from the geological point of view, but also from the economic point of view, because they are holding some of the copper mineralization and possibly the gold mineralization in Oman offline. And they are mostly basaltic rocks in composition. That is mafic rocks. This is one of the billows, and this is another billow, and this is another billow. So they are coming close to each other, and as you can see, the margin between them, sometimes if it's there, is a huge margin, because this comes and touch the water of the ocean and will be squished or quenched very quickly and producing some kind of very, very fine or altered materials due to this quenching with the water, with the adjacent ocean water. We are now in the Supergroup C, which I told you this morning, it's composed of concretes, is of tertiary age. And this area probably you will find more than one formation, starting with the oldest Al-Kiyumi, and then Seep and Lusail, and then Seep, different formations, and you will learn about those in detail for your in the future coming courses. But here I will just show you how to differentiate and what they are composed of. We are using HCl to test some of those rocks. For example, if you look at this one, you see how much is reacted. It's too much reaction because it is carbonate, and if you can see, it's much faster than the marble that we have seen in the early morning. Those carbonate rocks contains fossils, a lot of fossils, gastros and pilicifoids and other fossils that you can ask if you are taking a barrio 1. You can ask your instructors. You can see gastro there. And then if we go down a little bit here, we see some of the evaporites, the gypsum. I will show you the gypsum. That means reflecting. That is a very shallow marine environment, and in some zones it was just evaporation. Gypsum, which is, as I told you, is formed in a shallow marine environment. So this reflecting this whole sea super group. It's a shallow environment. Some localized, very shallow evaporated rocks. Very nice, and you can see it here. This is the gypsum. You can see not just nice gypsum. There is a lot of bits of this gypsum here. And here, this is all gypsum. Very nice gypsum. You can see those rocks have been tilted in this bus, which goes to Old Al-Khor. It has been tilted like this way. So they are leaving this way to the east. Okay, this is the end of the virtual field trips. I hope you will enjoy listening to it, and you will get something out of it. So please go through it, and if you have any comments or if you have any questions, please do not hesitate to send me an email or WhatsApp, then I will try to explain to further. Thank you very much, and enjoy your time. Thank you.